Hello, good morning everyone. Yes, we are going to start with today's lecture. So I'll start from the point where we left yesterday. We were doing root test. The questions are still need to be discussed. So I'll repeat the statement of nth root test for you. So this is a test which is applicable to series of non-negative terms. So let summation an be a series with non-negative terms. Then what we have to do, we have to evaluate the limit n tending to infinity, an raised to power 1 by n. So we have to take the nth root of it and get the value of the limit. And then by looking at the value of the limit, we will be deciding whether the series is convergent or divergent. So conditions are this: if rho is less than 1, then the series summation an converges. If rho is greater than 1 or infinity, so that's covered in the category of rho greater than 1, if the limit turns out to be infinite, then summation an diverges. And the third part says if rho is equal to 1, so test is inconclusive, or we can say test fails, means we are unable to write any fixed answer for the series. In that case, we will be using some other test to get towards the final answer. So this was the statement of nth root test. So now let's do some questions where we'll be applying this test. So let's do this example. Summation n is equal to 1 to infinity 2 raised to power n by n square. I gave you the hint yesterday that how will you identify whether we can try with nth root test or not. What is identification? Just like for ratio test, I told you that whenever you see the factorials in the question, so most of the time those questions are solvable using ratio test, because the calculations become simpler when you take the ratios of the factorials. Similarly, if you have the general term an, like there is n coming in the power, it's coming as a power, then it is recommended that you try with ratio test, root test, because you see how it's going to be simplified. So I'm doing this with root test. So this limit raised to power 1 by n. So you evaluate this limit. So this will be 2 n square raised to power 1 by n. Because in the numerator, you see it is n into 1 by n. It is n into 1 by n. So this will be balanced here. So that will be only 2. And in the denominator, it is n raised to power 1 by n whole square. Because the square is there, raised to power 1 by n. So I can rewrite it this way. So 2 is just a scalar. So this is nothing but 1 over n raised to power 1 by n whole square. So all of us know the value of this limit is 1. This is one of the standard limits we know. Limit n tending to infinity, n raised to power 1 by n is 1. So ये उसका square है, so that will also be 1. So the answer is 2. So now you have to compare with 1, because according to the statement, you have to compare the value of the limit with 1. So it's greater than 1, so the answer is divergent. So you will be writing this is divergent by nth root test. अकेला रूट टेस्ट भी बोल सकते हैं, nth root test भी बोल सकते हैं, but precise name is nth root test. So that was example 1. Now let's move to next example. Summation n is equal to 1 to infinity n raised to power 10 over 10 raised to power n. So since n is coming in the power, I can see n is coming in the power in the denominator. So I will try to simplify using the root test. So general term whole raised to power 1 by n. This limit I have to evaluate. So n raised to power 1 by n raised to power 10 by 10 n into 1 by n. So again, on the similar lines, this will be 1 in the numerator because this is the standard limit, and in the denominator this will be 10 because ये balance हो जाएगा. So ये 1 raised to power 10 है, so 1 raised to power 10 is 1, so it's 1 by 10 which is less than 1. Therefore, this is convergent by root test. So you see how easy it's done, how easily it is done using the examples. So this is example number 2 in which we got the answer as convergent. So let's do one more example. Summation n is equal to 2 to infinity n by log n raised to power n, right? So यहाँ पे भी in the denominator you can see there is a function of n and the raised to power is n. So power में n है, so we will try with root test. So n by log n raised to power n whole raised to power 1 by n. So this will be again n raised to power 1 by n log n raised to power n 1 by n. So ये n raised to power 1 by n again will be 1 over this will be log n because ये balance हो जाएगा. You see that's why the power balancing is happening all the time because n gets balanced with multiplied with 1 by n gives the power 1. So 1 by log n limit n tending to infinity we know it is 0 which is less than 1 therefore convergent. So you see that's how easy it is. The only thing which you need to know is how to compute the limits accurately. Let's do one more example of root test and after that we'll move forward to the next thing. Summation n is equal to 1 to infinity n factorial raised to power n over n raised to power n square. So here you can think about that since I told you that okay whenever factorials are present we try with ratio test. You can try with ratio test but here I will do it with root test because it's n is coming in the power. So I'll try doing this with root test. So this is limit n tending to infinity n factorial raised to power n raised to power n square whole raised to power will be 1 by n. क्योंकि न्यूमिरेटर की पावर में भी n है डिनोमिनेटर की पावर में भी n है तो आप रूट टेस्ट यूज करोगे it will be very much easy to solve the limit. This will be n factorial only because ये balance हो जाएगा and in the denominator also it will be just n square because वो भी n power जो है balance हो जाएगी. Yeah, so all of you just write your answers in chat box. Tell me the value of this limit. Limit n tending to infinity n factorial by n square. This is not any standard limit but you need to tell me the value of this limit. N factorial by n square. You try to see क्या है ये n n-1 n-2 up to 3 to 1 denominator में it's just n into n because it's n square. So you see one n gets cancelled and actually this is 1 minus 1 by n. इस n को आप इसके साथ adjust कर लो n minus 1 के साथ and look at the rest of the terms. Rest of the terms are this and this is 1 because 1 by n goes to 0. So actually this is infinity. You see the n is coming with the positive power in the numerator and so that's becoming as large as possible. So the answer is infinity. You can try looking at by substituting the values of n also. 3 factorial by 3 is 3 square is 6 by 9. 4 factorial by 4 square, you know, that is 24 by 16. 5 factorial by 5 square 120 by 25. So you see as n keeps on increasing the numerator is becoming very large. यहाँ पे छोटा था but as n goes to infinity the numerator will become very large as comparison to the denominator, so it will go to infinity. This is not a way to give the answer. The way is just directly you have to write infinity. You have to show by the calculations, but this is just to understand that actually this is happening. So this was example 4 and this infinity is obviously greater than 1. So the answer is divergent for this question. Right, so I'll be showing the previous slide. Somebody is asking to show me the previous slide. In meanwhile, I can launch a question. I'll be giving you a few questions to solve and then we'll be moving ahead towards the next topic. So example 3 में I can explain again if you have doubt. It's just I raised to power 1 by n. न्यूमिनेटर में n रेज टू पावर 1/n बना विच इज 1, डिनोमिनेटर में log n होल की पावर n था raised to power 1/n, so it's just log n. So 1 by log n is 0. We know that 0 is less than 1, therefore this is convergent. Don't worry about noting it down. I already told you I'll be sharing the notes with you. Right? So the next one was divergent. So that's all about the root test. So let me just summarize here what we have done so far. So we have done for series of positive terms, positive, or we know the word is जनरल वर्ड इज नॉन नेगेटिव. हमने ओ वाली सीरीज कंसिडर की हैं जिनमें सारी टर्म्स पॉजिटिव हैं या नॉन नेगेटिव हैं. सो वी हैड 4 टेस्ट फॉर देम: इंटीग्रल, कंपैरिजन, and then we had the ratio, and then we had the root test. So all of these are for these series of non-negative terms, right? So now the question here should be asked that what is the other type of series. हम ये कह रहे हैं कि ये पॉजिटिव सीरीज है, ये नॉन नेगेटिव सीरीज है. सो द क्वेश्चन रिमेन्स, इसके अलावा और कौन सी सीरीज हो सकती है, राइट? सो प्लीज, या ऑब्वियसली यू आर मेंशनिंग nth टेस्ट, वो जनरल टेस्ट है, वो मैं बार बार नहीं लिखती हूँ. जो जीपी सीरीज है, टेलीस्कोपिंग है और nth टर्म टेस्ट है, वो जनरल है, वो पॉजिटिव नेगेटिव नहीं होता है, वो कोई भी सीरीज हो सकती है. जीपी, टेलीस्कोपिंग और जो nth टर्म टेस्ट है वो भी किसी भी सीरीज के ऊपर अप्लाई हो सकता है. बट पॉजिटिव टर्म्स के लिए वी हैव स्ट्रिक्टली दीज 4 टेस्ट. सो व्हाट इज द अदर टाइप ऑफ सीरीज? सो द अदर टाइप ऑफ सीरीज इज, सो यू कैन थिंक अबाउट इट एंड गिव मी एन आंसर. सो एक तो ये सीरीज है, से a1 plus a2 plus a3 and so on, where all ans are greater than equals to 0. ये हम कर चुके हैं. सो नाउ यू जस्ट टेल मी और क्या ऑप्शंस है आपके पास AIs के बारे में. सारे AIs नेगेटिव हो सकते हैं. This can be your series a1 plus a2 plus a3 plus a4. All ans are negative. This can be other type of it. And what else can be? It can be a1 minus a2 plus a3 minus a4 and so on. ans are positive. इसमें मैंने रखे तो पॉजिटिव हैं थर्ड वाले में, बट यू सी ऑल्टरनेटिवली मैंने सब्ट्रैक्शन साइंस इंट्रोड्यूस कर दिए हैं. दे आर ऑल्टरनेटिवली बिकमिंग positive and negative. Means if you look at the second term of the series, this is negative because a2 is positive but minus a2 will be negative. So you can see there are 3 types of series: the positive term series, the negative term series, and the alternating series. Right. Now I will tell you that it is useless. Useless means there is no need, actually I should not say useless, there is no need to study for the negative series. आपने बोला कि पॉजिटिव सीरीज के लिए टेस्ट हैं तो नेगेटिव सीरीज के लिए भी अलग से टेस्ट होने चाहिए. You don't need them actually. So can anybody tell me why do you don't need any test for negative series? It's sufficient to know the test only for positive series. Negative series means जिसकी सारी टर्म्स नेगेटिव हैं, उसकी कन्वर्जेंस डाइवर्जेंस आप कैसे चेक करोगे? या माइनस कॉमन, that's a very good answer. You just take minus common and you whatever you will be left with is a positive term series. So you can say the negative term series is just a scalar multiple of the negative term series is a scalar multiple of positive term series. And we know the results about convergence divergence कि whatever is the original series convergent or divergent, scalar multiple of that series remains same. Means scalar multiple of convergent is convergent, scalar multiple of divergent is divergent. That is why negative series का अपना कोई ऐसे sense नहीं है उसको अलग से discuss करने का, because it is just acting as a scalar multiple of the positive series. तो जो टेस्ट पॉजिटिव पे लग रहे हैं नेगेटिव पे भी वही लगेंगे. इट्स जस्ट नेगेटिव विल बी टेकन आउट एंड यू विल फाइंड ऐसा कोई क्वेश्चन नहीं मिलेगा आपको बुक में. इनफैक्ट ये पॉइंट कभी डिस्कस ही नहीं किया जाता है बिकॉज ऑफ दिस ट्रिवियल रीजन. So I hope that is clear. So therefore essentially there are only 2 types of series, the positive ones and the important one which is alternating series. So now we'll be focusing all our attention to the alternating series, because the tests which were so far applicable to the positive term series, they will no longer be applicable to a series of the alternating type. So let me give you the definition formal definition of an alternating series, right? So the definition is a series in which the terms are alternatively positive and negative is called alternating series, right? So the definition is very easy to understand. Ek term positive, ek term negative, positive negative, positive negative, it has to happen alternatively, so that series is called alternating series. You can create plenty of example. 1 minus half plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 and so on. So obviously ये भी infinite series है, but you see the terms are alternatively positive negative. पहली term negative हो सकती है, second term से positive, so that does not matter. What matters is the sign should be alternatively positive and negative. So you can have other examples, 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on. So in this form you can create any example of your own, right? So now we will be again addressing the same question. The question is still same into the picture, convergent or divergent. So we need to look for when does an alternating series is going to converge or diverge. So as I told you, the test which we have already done for positive term series, they will not be applicable. These all tests will not be applicable on the alternating series. So alternating series का अपना ही एक test है which is called alternating series test, or this is also called Leibniz test because this was given by Leibniz in the form of a theorem. This is a statement of a theorem. So we are not going to do the proof of it. We are just going to look at the statement and we will be applying this. So you just understand it's just a test. जैसे हर टेस्ट की एक स्टेटमेंट होती है, so इसकी भी एक स्टेटमेंट है, but it's clear from its name it is only applicable to alternating series and no other type of series. So let me first give you the notation of an alternating series. So वो आपको clear हो जाएगा after this statement. So I'm writing the alternating series summation n is equal to 1 to infinity minus 1 raised to power n plus 1 un, which is u1 minus u2 plus u3 minus u4 and so on, converges if all three of the following conditions are satisfied, right? So this statement tells you कि एक series है alternating series, it's just the notation is different. यहाँ पे मैंने आपको ये बताया था a1 minus a2, but यहाँ पे we are writing it as u1, that is the notation. So this complete is actually an, but we know an alternating है तो it's of a particular type. So we know that particular type alternating जब भी positive negative generate करने होते हैं, so it always comes in the form of minus 1 raised to power n plus 1, because the moment you put n equals to 1 वो वाली term positive होगी and then alternatively negative positive. So उसके साथ जो बाकी बचा है उसको हम un से denote कर रहे हैं. So this an is completely this one जिसके दो parts हैं. एक part है sign generate करने के लिए, ये वाला part, और दूसरा part है remaining function of n. So this is u1 minus u2 plus and so on. So we are saying this series is going to converge if the following three conditions are satisfied. So what are those three conditions? First condition is un is positive. Second condition is un is greater than equal to un plus 1 for all n greater than equals to n. And the third condition is limit n tending to infinity un is 0. Right? So let's understand these three conditions one by one. So the first condition means that un should be positive. So it's clear. I told you आपकी overall series क्या है alternating, तो उसको दो parts में, उसकी term को दो parts में लिखा है, where this part minus 1 raised to power n plus 1 is for generation of positive negative signs, while the rest of the part is the just positive. So this un is something positive. So you can take an example like minus 1 raised to power n plus 1, 1 by n. So this is your complete general term of the series, out of which this part is for alternating signs, while the rest of the term means this one only, 1 by n, we know that is positive. So this un should be positive. Second condition is un should be greater than equal to un plus 1 for all n greater than equals to n. So I have already explained you the meaning of for all n greater than equals to n, this type of expression when we were dealing with integral test, and this actually means it is a decreasing sequence, मीन्स जो un बनेगा वो decreasing है. So I'm not using the word sequence so that you don't get confused in sequence and series, but you just know this condition should be satisfied, that the terms should follow a decreasing pattern, that the nth term is greater than or equal to the n plus 1th term. And for all n greater than equals to n, we already know its meaning, that the decreasing behavior of the terms may not start from the very first term, but it may be like कि starting में it's increasing or it's oscillating, whatever it can be, but there exists a capital N, उसके बाद it is monotonically decreasing. So that behavior should be shown by the general term of this as un. And the third condition is this should be 0. The un should go to 0 as n goes to infinity, and you know this is nothing but the coming from the statement of nth term test. If you remember nth term test, I told you the nth term test is a general test. It's applicable to all the type of series. So that is also applicable here also. And what is the statement of that test? That if a series is convergent, then its nth limit has to be 0. So that's why this limit n tending to infinity un has to be 0. So the questions will be like, you will be verifying all these three conditions, and if all the three conditions are satisfied, we will be writing the series, this alternating series is convergent. Right? So let's now do the questions so that it will be clear to you even more. So for the beginning, just for the starting, I'm taken a very simple example. So summation n is equal to 1 to infinity minus 1 raised to power 1 by n plus 1, 1 by n. This is basically alternating harmonic series. It's just for the additional information I'm telling you the name. So we know that harmonic series is simply summation 1 by n. And this one is minus 1 raised. This is an alternating harmonic series. So let's apply the test. So to apply the test, you need to identify un. So un is 1 by n. So as you can see, this is of this form, minus 1 raised to power n plus 1 un. So your un is 1 by n. So what are your three conditions? First condition is un should be positive. So 1 by n should be positive. So satisfied. And I'm telling you this will be most of the time satisfied. It's trivial condition, but you need to write it just to show that you know the three conditions. Un should be greater than or equal to un plus 1. So 1 by n should be greater than or equal to 1 by n plus 1, which is also true. Right? It's clearly true because we know that n plus 1 is greater than n. So 1 by n is greater than 1 by n plus 1. अब derivatives से भी prove कर सकते हो decreasing. You know there are 2-3 ways to prove the decreasing. So whichever suits you. But यहाँ पे ये ऐसे ही easy था just by putting the values of the general term. So that's why we just wrote it like that. Otherwise, in some examples we will see हम derivative वाले method से भी decreasing जो है prove कर सकते हैं. So second condition is also satisfied. And the third condition just is limit n tending to infinity 1 by n, means un, that should be 0. This is also true, clearly. No need to give any justification. This is true. So all the three conditions are satisfied. So after that, you just need to write all the three conditions are satisfied. All the three conditions of alternating series test are satisfied. Therefore, this series is convergent. Right? So that was a very simple example to start with. We just verified these three conditions and then we proved that the series is convergent. So we got to know one thing, one result, that this alternating harmonic series is convergent. But if you remember the ordinary one, the जो इसका positive series वाला part था, if you just talk about harmonic series, summation 1 by n, we know that that is divergent. We have proved that using P series test, using integral test we have seen. So this is divergent, but इसका जो alternating वाला part है, if that series takes the alternating form, that becomes convergent. Anyways, we are not going to just as a cramming of these results. It's just I'm showing you for the comparison. So let's do more examples for the same. Right. So n is equal to 2 to infinity minus 1 raised to power n plus 1 by log n. So you see it's an alternating series. So पहला काम तो आपको यही करना है ना कि आपको आइडेंटिफाई करना है कि आपकी सीरीज की टाइप क्या है. If it is a positive term series, so we know out of those 4 tests, one of them will be applicable: integral, comparison, ratio or root. Or if it is alternating series, then there is only one test, which is the alternating series test. So clearly this is an alternating series. So un is 1 by log n. I will write down, and now I'll be verifying the three conditions. So first condition, un should be positive. We know that this is positive, 1 by log n. n आपका 2 से इसीलिए यहाँ पे start हो रहा है index, because log 1 we know is 0, so that term will not be defined. So it's positive. सेकेंड क्या प्रूव करना है आपको? डिक्रीजिंग. un should be greater than equal to un plus 1. That is also true, because we know that you can give the reason log of n plus 1 is greater than log of n, so reciprocal of that. So this is also true for all n. And the third condition is limit n tending to infinity 1 by log n should be 0, which is true. We know that is 0. So आप ऐसे मत सोचना मैं सिर्फ लिख रही हूँ उसको. I'm actually solving them. It is just the calculations are so trivial, they don't need any explanation. We know that the value of this limit is 0. So here also you will be writing your answer as convergent, as all the three conditions are satisfied. Right? Now moving ahead towards the next example. Summation n is equal to 1 to infinity minus 1 raised to power n plus 1, 3 square root of n plus 1 square root of n plus 1. So you see in the numerator ये पूरा square root में n plus 1 है, while in the denominator it is just square root of n and then there is plus 1 separate. So I clearly identified, okay, yes, this is alternating series, so I'll be applying the test on it. So first is un. Un is 3 square root n plus 1 by root n plus 1. Yeah, so this is my un. So the first condition is un should be positive. It's clearly positive because we know n is a natural number. So we know this term, there is no subtraction involved. All functions are giving positive values. So this is positive, satisfied for all n. Second condition, we need to check the decreasing. un should be decreasing, means un should be greater than equal to un plus 1. So जो हमने अभी पहले दो examples किए हैं, there un was very easy, so we could directly write it just by that way because it was trivially very easy to look at that. But this function is needs little bit detailed calculation, so I will not be doing it this way, rather I'll be doing the derivative way. So you find out the derivative, and then if the derivative turns out to be negative, so we will say it is decreasing. So all of you are supposed to tell me the value of the derivative of this function. Solve this and give me the answer. This is your un. What is un dash? Right? Right, so I'm just leaving this calculation for you. You can verify this If you don't get it, you can ask me later on, but it's just with a little bit more calculation, it will be very easily proof that this is negative. So this one is like that. And I'm actually picking up this example just to show one thing. Let's just first verify the third condition. So limit n tending to infinity. Just let me know the value of this one. What is this? All of you evaluate this limit and write your answers in chat box and tell me the value of this limit. 3 square root n plus 1 divided by square root n plus 1. Initially, you can see it will be infinity by infinity. So, or you want to apply L'Hopital, that's fine. Otherwise, you can simply divide by square root of n in the numerator and denominator. It will be very easily to solve this one. And you will see the value of the limit is 3, which is clearly non-zero. So now completely you just forget about the nth, you forget about the alternating series test or whichever series we are dealing with. This is nothing but we are testing the nth term test. This is something I told you when I told you the statement of alternating series test, that the third condition of that is nothing but nth term test only. So we know the nth term test, if the limit turns out to be non-zero, so we know the answer is divergent. So you have to write divergent by nth term test. So the same thing you can also interpret in this way, that although this is an alternating series, but still nth term test is applicable. I told you nth term test is general test that is not requiring the series to be positive term or alternating. It is applicable to any type of series. This is a complete nth term of it. So if this much part of this is non-zero, it's further just multiplied with minus 1 raised to power n plus 1, but it will still keep it non-zero, or the limit will not exist. So whatever it will be, you will be writing divergent by nth term test. You are not supposed to write divergent by alternating series test, because the alternating series test is there to tell you only the convergence. So I will be now rephrasing my statement. The statement tells you, the test statement tells you 3 conditions which needs to be verified. This one is the first one, which is most of the times trivially satisfied in almost all the examples. So the just choice is between the second and third condition. So I'll be telling you the order in which need to verify the conditions. The recommendation is, first you will be verifying this condition, third condition. So the third condition should be tested first, because that is nothing but nth term test. क्योंकि वहीं से अगर आपकी लिमिट नॉन जीरो आ गई, you can straight away write divergent. No need to check the decreasing or wasting time on doing the calculation. Just like we were doing in this question, we just left this in between, right? But we moved to the third condition and then got the answer just from here by nth term test. So that is my recommendation. ये example मैंने इसीलिए लिया था, that sometimes you will end up wasting your time and calculations on checking the second condition, but when you go to the third condition, you see, okay, it is divergent. So there was no need to actually do this one. So you reconsider your order of the conditions which needs to be checked. Firstly, we'll be writing this one. Second, we'll be verifying the limit condition. And if the limit turns out to be zero, only then you go towards checking of the decreasing condition. Otherwise, if limit does not turn out to be zero, question finishes there only. We will be writing it is divergent. I hope that is clear to all. So that's why I also took this example to make this point clear, and this will be very much applicable to many more examples where it will be beneficial to check the limit condition first using nth term test. Yes, if Shrishti, you're asking me in case of nth term test, it is inconclusive, the limit is zero. Yes, but from nth term test, then we are not implying the limit zero interpretation. We will be moving ahead towards the second condition. So when this second condition of this test will be applicable, then since the combination of these 3 conditions are satisfied, then according to alternating series test, that will be convergent. You are true in your understanding, you are right in your understanding कि अकेले limit zero आने से हम convergent नहीं लिख सकते हैं. That is why I am saying कि जब limit zero आ जाएगी, you have to check this second condition. If that gets satisfied, then according to the statement of alternating series test you can write convergence, right? और ये वाला particular question, ठीक है, it's not decreasing, but we are not checking the decreasing increasing because हमें यहीं पे पता चल गया है this one is divergent, right? yes, ऑल्टरनेटिंग सीरीज के लिए जब लिमिट जीरो आ जानी है आपको उसके बाद डिक्रीजिंग चेक करना है, दैट्स व्हाट आई एम सेइंग, बट लिमिट नॉन जीरो आते ही आप डाइवर्जेंट लिख सकते हो. दिस इज द पॉइंट आई एम ट्राइंग टू convey. So I'll just summarize here. So first you check this condition, second you check limit n tending to infinity un. जब भी आप ऑल्टरनेटिंग सीरीज का क्वेश्चन कर रहे हो उसके लिए मैं आपको ऑर्डर बता रही हूँ. फर्स्ट दिस कंडीशन नीड्स टू बी चेक्ड विच विल बी ऑलवेज सेटिस्फाइड. Second, this one, you evaluate the limit. Whatever the value of this limit turns out to be, say this is, say L. Now यहाँ पे दो cases बन जाएंगे. If L is non-zero, you write divergent. Question finishes there only. If L is zero, then you further check the condition, the third condition, which is decreasing one. Un should be greater than equal to un plus one. और obviously यहाँ पे भी दो चीजें होगी, yes है कि no है. If it satisfies yes as decreasing, means if it turns out to be decreasing, then obviously your answer has to be convergent, right? yes, only yes पे आपको ये convergent answer देना है. This is going to happen. But अगर यहीं पे divergent है, then no need to check the third condition. I hope that is clear to everyone. Right, so that was all about this alternating series test. So I'm giving you few examples which you can try at home, and moreover you will be finding plenty of questions in the book as well as in the tutorial sheet, so you can do the practice. So these two examples you can practice and give me the answers tomorrow, means whenever we'll be meeting next. So the next thing which we are going to talk about is absolute convergence. So I'm just going to tell you the meaning of the absolute convergence. Questions हम next time करेंगे. So I'm just taking the definition of it. So now we are talking about a new kind of convergence. इससे पहले जब हम बात कर रहे हैं, अभी तक हमने जितने भी questions discuss किए हैं, we were always concerned about convergent or divergent. But now we are introducing a new term which is absolute convergence. So this is a new kind of convergence we are going to talk about. Why this makes sense to talk about absolute convergence now? Because we are dealing with alternating series. इससे पहले जो हम सीरीज की बात कर रहे थे, they were positive term series. So जब सीरीज की सारी टर्म्स हैं ही पॉजिटिव, so we know that कि उनका चाहे आप टर्म्स का मॉड लो चाहे ना लो, that's one and the same thing because they are by default positive term series or the non-negative term series. तो वहां पे we were not distinguishing between the absolute convergence and the convergence. You can say default convergence there was the absolute one, but here when the series is alternating, so you have to be carefully looking at whether what kind of convergence it is. So let me first give you the statement of the definition of absolute convergence, then you will understand the meaning of it. So this says a series summation an converges absolutely if summation mod an is convergent. So this is a general definition applicable to any type of series. So as I just told you कि positive term series के लिए mod an और an same ही होते हैं, तो वहाँ पे हम distinguish नहीं करते हैं, वहाँ पे convergence and absolute convergence है one and the same meaning, तो हम उसको सिर्फ convergence ही बोलते हैं. But alternating series में an और mod an वाली series में difference होगा, they will be two different series, so therefore we need to talk about that term here. So we are saying a series is going to converge absolutely if mod of an is convergent. So all what you have to do is take the mod of the general term and then you check the convergence. So if that turns out to be convergent, then we say our series, whatever will be the given series to you, is absolutely convergent, right? I'll give you example here. For example, you are given the series n is equal to 1 to infinity, say minus 1 raised to power n plus 1, 1 by n square. Now this is my an. ये पूरा an है मुझे given. What will be mod an? What will be mod an? It will be simply positive part of it and that is 1 by n square. So mod लेने से हमेशा यही होगा, जो -1 raised to power n वाला part है, -1 raised to power n और -1 raised to power n plus 1, that will be gone and बाकी जो भी है positive part, that will you will be retaining. So just the absolute version of that you have to do. Now this as a series, if you look at it, this one, so summation 1 by n square, because I have to check the convergence of mod an. So पहले मैंने mod an evaluate किया, that is 1 by n square. So this summation 1 by n square, yes, everybody knows the answer for it. Is it convergent or divergent? Convergent, we know that it's convergent from p series test. So ये mod वाली जो series हमने ली, that turns out to be convergent. Therefore I will be saying this series जो originally मुझे given थी, this series is an example of absolutely convergent series, right? अब क्वेश्चंस में कैसे करेंगे या किस तरह में इसकी एप्लीकेशन होंगी, विल कम टू दैट लेटर, बट दिस टाइम वी आर जस्ट गोइंग टू अंडरस्टैंड द मीनिंग ऑफ इट, द डेफिनेशन ऑफ एब्सोल्यूट कन्वर्जेंस, दैट यू जस्ट हैव टू टेक द मॉड, और मॉड वाली सीरीज विल ऑलवेज गोइंग टू बी अ पॉजिटिव टर्म सीरीज, बिकॉज उसमें से आपने नेगेटिविटी तो हटा दी है, वो एक पॉजिटिव टर्म सीरीज में कन्वर्ट हो जाएगी, और इस पॉजिटिव टर्म सीरीज की कन्वर्जेंस चेक करने के लिए वी नो वी हैव ऑल द मेथड्स, whatever will be applicable, we will find an answer whether it is convergent or divergent. So if that mod 1 series is convergent, we will say the original series converges absolutely, right? So yeah, that's all for today. 1 by n square is convergent from p series test. Yes, I can take 1-2 questions. Yes, Vidushi.
Question is that n factorial upon n to the power n, ma'am, which test will be applicable?
N factorial over n raised to power n. Yeah, you can try with ratio test. Have you tried with ratio test?
No, ma'am, I was trying with that only factorial one.
Ratio, oh, yeah, it will be doable with ratio test. I can see that. Try with this. Otherwise, I'll give you an answer next time. ये हो जाएगा ratio test से.
मैम एक था कि 1.3.5 से लेके 2n-1 तक अपॉन 4 की पावर n
Hmm.
पावर n
Yeah,
into n
these
factorial.
these will also be doable using ratio test, because I told you ratio test में factorials या product of terms जब आते हैं तो because जैसे आप ratio लोगे तो वो बहुत सारी terms cancel out हो जाती है, तो ये भी ratio से ही होगा. आप ट्राई करो इसको रेशियो टेस्ट से.
हम तो फिर ये सीरीज को कैसे लिखेंगे हम उसके टर्म्स में n
यही
को?
यही जनरल टर्म है, आपको बस पूरी सीरीज लिख के क्या करना है, दिस इज जनरल टर्म. आप ए एन है, आप एन को n+1 चेंज करो एंड देन यू सी व्हाट हैपेंस. यस चैतन्य, व्हाट्स योर डाउट?
मैम ये लेबनीज टेस्ट में अगर लिमिट 0 है पर बाकी कंडीशन सेटिस्फाई नहीं कर रही तो क्या होगा?
बाकी मतलब पहली तो
मतलब अगर डिक्रीजिंग नहीं है.
लिमिट 0 है बट डिक्रीजिंग नहीं है.
यस मैम.
Okay, actually वो that is an exception kind of example. I'll give you that example tomorrow कि तब क्या होता है. तब हमारे पास actually कोई implication नहीं है. That's why I wanted you to raise this question. तभी मैंने इसको open रखा था, मैंने आपको नहीं बताया यहाँ पे क्या है. थर्ड कंडीशन सेटिस्फाई हो गई मीन्स डिक्रीजिंग हो गया, तब तो डेफिनेटली कन्वर्जेंट है बिकॉज दैट इज द स्टेटमेंट ऑफ द टेस्ट. बट वॉट एवर इट्स नॉट डिक्रीजिंग, तब क्या है,
यस
दैट
मैम.
स्टिल अ क्वेश्चन मार्क. एक्चुअली क्वेश्चन मार्क मीन्स हम फिर ये टेस्ट से कुछ इम्प्लाई नहीं कर सकते. इन दैट केस वी हैव टू एग्जामिन द सीरीज फ्रॉम अ सम परस्पेक्टिव टू सी, क्योंकि ऑल्टरनेटिंग सीरीज के लिए कोई और टेस्ट तो है नहीं है कि और कोई टेस्ट लगेगा. फिर हमें सीरीज को कुछ करना पड़ेगा, हमें सीरीज टू सीरीज ये डिपेंड करेंगे उसकी रीअरेंजिंग या री-इंडेक्सिंग करके. आई विल गिव यू एग्जांपल टुमारो, देन इट विल बी क्लियर.
ओके मैम.
दिस इज गोइंग टू हैपन इन वेरी वेरी रेयर एग्जांपल्स, right? So that's all about this today. Rest of your doubts I'll take the next time. And yeah, that's all from me for today. Bye.